Hi all. In this last video, I want to go over some important metalogical concepts. In the text, there's some deeper examples. I'm just going to skate over the surface. Broadly, there's two types of logics. There's classical logics and constructive logics. Hoc is a constructive logic where whenever we prove anything, we have immediate evidence for it, right? When you prove an or, you've chosen either the left or the right branch to go down. When you prove an exists, you've provided a witness. Now, classical logics admit a principle Koch does not that undermines this idea of always having constructed an answer that you can actually look at. That principle is called the principle of the excluded middle, or the law of the excluded middle, or simply the excluded middle. Um, so what is the excluded middle? Here, the excluded middle is saying there's nothing in between true and false. That's the middle being referred to, and it says for any proposition P, either P holds or not P holds. This is not a theorem in Koch. It cannot be proved. And it is taken as a theorem in classical logics, which are the logics that mathematicians work in by default. Now that said, you can consistently add it to Koch. You could assume this and do a bunch of proofs, and it's not like your logic will break down or explode because this is inconsistent or wrong or not possible. It's perfectly fine to consider this world. You lose some of the benefits of Koch's constructiveness, the idea that, for example, you've written a program that you can extract and it constructs an actual answer and always has evidence for its proofs. Uh, you'll lose that if you add an axiom like this, but you can have it. We're not going to really delve too deeply into any portion of that in this course. This is sort of an advanced logical concept, but I wanted you to be aware of the existence of the excluded middle and the fact that the logic we're working in doesn't have it. We're not really going to have to pay a high price to avoid using the law of the excluded middle, but there's a lot of mathematics that are really hard to do if you don't allow them. Um, we're not going to do those. A lot of it has to do with fancy number stuff, and we hardly even work with numbers at all. One thing I do want us to engage with, I'd love for you to read the text and sort of there's some nice interesting examples there that shows sort of the problems with non-constructive or classical proof. Uh, but also there's a final exercise here that I just wanted to sort of talk through. So related to the law of the excluded middle, in classical logic, for all and exists are dual. If you negate one, you get to the other. So we've proved some of this for dis not exists and dis not for all. These are lemmas in the homework that are further up in this file. So here's a sort of other versions of those lemmas. Not exists x, p of x should imply that for all x, not p of x. If you can't find an x such that p of x holds, then for every x, p of x doesn't hold. Similarly, if it's not the case that any x has p of x, then there should be an x that doesn't have p of x. Okay, these are two theorems. Both of these theorems hold in classical logics, right? They're standard theorems that exist that are provable there. In Koch, only one of these is provable. So what I'd like you to do is to prove exactly one of them. The other you can leave admitted, or you can write abort at the end if you want to write abort for some reason. Both are fine. And then we'd like you to comment at the end, like, why does the one that not work, why does the one that doesn't work not work? Right? One of these you'll be able to prove, the other you won't. What's going on? Why are you unable to prove one of them? Okay, so I wanted to coach you through that. If you have any questions about this, ask on Zulip. If this is interesting to you, I would love to talk with you about this sort of like choosing the structures and like ways your logic works. So I do some research in logic, and I'd be happy to work with y'all on that. If it's not interesting to you, this will basically be the last we talk about it. So sorry to bother you. All right, that's it for today. Not a super long file. If you have any questions, I'll see you on Zulip. Talk to y'all soon.